Hello again. So nice to see you. Remember in that last video where I said that the thing I love most about cloud computing is the ability to just delete things and recreate them? Well, I did that with my home cluster, and then when I went to rebuild it, I thought to myself,
Why not film all the ways to install K3s?
and then I thought, that's a great idea. So here I am to show you 5 different ways to install K3s. K3s is the lightweight Kubernetes distribution created by Rancher Labs. It removes much of the default bloat that's available in stock Kubernetes, such as storage providers for every cloud provider, alpha components, and other bits. And then it bundles Containerd, Flannel, Traffic, a local path provisioner, host utilities, and a service load balancer into a single binary. This makes it a complete all-in-one, batteries-included production distribution of Kubernetes that runs with the smallest possible footprint. The binary itself is under 100 megabytes, and when running, all of the Kubernetes components use less than 512 megabytes of RAM. It's easy to question how K3s can be a production distribution of Kubernetes. I mean, how can it be so small, but so much better than the alternatives? People look at it like Minikube or MicroK8s or Kind or other distros that aren't fit for production, but K3s is different. It's designed for multi-node HA operation in resource-constrained environments like IoT and the edge, but it's just as much at home in the data center as it is in a fighter jet or a wind farm. The fastest way to install K3s is on a single node. This gives you a single server that acts as both the control plane and a worker. It's obviously not HA, but there are lots of places where a single node Kubernetes cluster has value. As long as whatever it's managing isn't mission critical, and you have a path for recovery or replacement of the node, you might find that it's faster to bring up a new node and reinstall the manifests than it is to manage an HA deployment. We install K3s by pulling down the install script and piping it to SH. Alternatively, you can just download it, review it, and then execute it when you're comfortable that it's not going to damage your system. The script fetches K3s if it's not already on the system, installs it and creates symlinks, deploys a systemd unit, and then starts it up. All in all, excluding the time it takes to download, you're up and running in under 10 seconds. K3s is a completely self-contained binary. It includes Containerd, its tools, and kubectl. You can either type kubectl directly, or you can type K3s kubectl if you prefer. Ultimately, they're the same thing. You can see in the output that we have a single node cluster. When the cluster first comes up, it writes out a kubeconfig file to etc rancher k3s k3s.yaml. This is the default location that K3s looks at when called as kubectl, and if you copy it off of the host and change the address for the server, you can use this with kubectl on any other machine. Once you have a server, you can start adding agents to it. By default, in K3s, all servers are also agents, so they'll run workloads if you don't add restrictions that prevent them from doing so. We'll see more about that in the next section. There's a file on the server at var-lib rancher K3s server called node token. This contains the token that authorizes agents to join the cluster. Copy it, and then head over to one of your agent nodes. You can pass the token in directly to the command to join the cluster, or you can save it as an environment variable first. This is also true of the K3s URL environment variable. Set this to the address of the server's API port, which will be an HTTPS endpoint on port 6443. By using environment variables for these two values, we can run the exact same command on the agent as we did on the server. K3s recognizes that having a value in the K3s URL variable means that we want to be an agent. The process happens as quickly as it does to install the server, except it runs K3s agent instead of K3s server. We can see back on the server that now we have an agent attached to our cluster. What if you want to uninstall K3s? Uninstalling it is just as fast as installing it. Every installation places an uninstall script into user local bin called K3s uninstall.sh for the servers and K3s agent uninstall.sh for the agents. Running this script removes all trace of K3s from the system. Poof, like it never existed. All right, this is easy, right? But there's got to be a way that we can make it easier. You might have heard of tools like OpenFast, Inlets, or Arcade, which are all projects from Alex Ellis. I'll put a link to them in the video description. One of his tools is Ketchup. and it performs an installation of K3s over SSH. Ketchup is a binary that you install by downloading it and dropping it into your search path, or you can use Arcade to install it. Once you have it, you can fire up a K3s server with Ketchup install, passing it no more than the IP of the host. Each version of Ketchup is pinned to a version of K3s, but they move with different release cycles. If there's a newer version of K3s that you want to install or upgrade to, you can tell Ketchup to use that version by passing the K3s version flag. Ketchup defaults to performing installations as root, so even though I pass that in with the user flag, it's not actually necessary. Sometimes I perform an installation on a system with the Ubuntu user, so I'm just in the habit of always using --user. It performs the installation, and then it prints the kubeconfig file to the screen. It also downloads the file to the local directory and adjusts the server key to point to the new server node. Once you set your kubeconfig environment variable to use this file, you can immediately start working with the cluster. Use ketchup join to install agent nodes. For these, you only need to pass in the IP of the node, the user account if you're not using root, and the IP and user account for the server node. If you overrode the K3s version, then you'll need to specify that for the agent as well. Ketchup will reach out to the server, retrieve the token, and then use that to attach the new agent to the cluster. I always use Ketchup to install K3s. It behaves more like RKE, and I like that I don't have to SSH directly to nodes to perform the installation. You can see here that we've got a 3-node cluster up and running, and it just took under a minute. By default, all K3s nodes act as agents, which means that workloads can be scheduled to the servers. And what if you don't want that? If you want to keep them isolated, then you'll need to taint them. Now, this isn't special to K3s. This is a standard Kubernetes action. So let's taint our server with K3s control plane equals true and the effect of no execute. This will prevent workloads from being scheduled to it unless they tolerate that taint. If you know that you want to taint the server or an agent, you can do that during installation by using the node taint flag and designating the taint that you want to apply. This only works at install or registration, so you don't have to worry about remembering to use it when doing an upgrade or performing any other maintenance tasks. When you're running K3s with a single server, it uses an internal SQLite data store. If you want to run it with high availability, then you have to point it to an external data store. This could be an RDBMS like MySQL, MariaDB, or PostgreSQL, or it could also be an etcd cluster. Wait, SQLite? Isn't that like not a real database or something? SQLite is actually fine as a database. It's not HA, but for things that need RDBMS functionality locally, it works great. It's robust, it's easy to manage, and it's easy to move data around. Kubernetes just needs a key value store, and SQLite is a lot smaller and a lot easier to manage than etcd. For single node clusters running in places where reliability matters, SQLite is less likely to cause issues than etcd. I mean, it's just a file. The library for interacting with it is built into K3s. There's no other program that can crash or that needs RAM and CPU, so for K3s, SQLite's kind of perfect. Depending on when you watch this video, the documentation might still make reference to an experimental internal data store using DQLite, the HA version of SQLite. This is deprecated, and at the time that this video was released, work was underway to use an embedded etcd for HA when an external data store isn't an option. I prefer to only talk about things that are, so I'll talk about using an external data store, and for this example, I'll use MySQL. My MySQL data store is a 2-node Percona cluster, and it's secured with a self-signed TLS certificate. K3s will need to know about the CA for that certificate so that it trusts the communication. It's possible to use certificates for authentication between K3s and MySQL, but I'm not using that here. Instead, I'll just use regular authentication with a username and password. Both nodes that will become servers need to have the CA certificate installed. So for me, that's K01 and K02. I copied the cert to each of them, and I assigned its path to the K3s data store CA file variable. Then I set the K3s data store endpoint variable to the MySQL connection string. This string is a combination of username, password, a TCP connection string that points to the database host and port, and the database to use. It's unreasonably complicated, but just make it look like that and you'll be fine. For me, That address is an address that lives on the load balancer. It's a 2-node Percona cluster. So this is a good time to talk about using a load balancer for this configuration. The documentation refers to a fixed registration address, which is a fancy way of saying an address that will map to both server nodes. The agents will use this for registration, and it's a big part of the HA composition of the cluster. You can also use it with kubectl so that if one server is down or unresponsive, traffic automatically goes to the other one. You don't need this to be a load balancer. It could be an address that the nodes share via keep alive D or something like an elastic IP. It could be a DNS record with multiple addresses, although round-robin DNS has its own set of problems when a node is down. For me, in this installation, it's an HA proxy load balancer configured to send traffic to both server nodes. The documentation says to configure this address after bringing up the server nodes, but I configured it before so that I could use it with the tls-san directive, and so that the certificate that K3s generates includes the load balancer IP as an alternative address. Without that option, I wouldn't be able to connect to it. kubectl would throw an error. All right, now let's initialize one of the server nodes and wait for it to become ready. After that, we initialize the second server node the exact same way. It will discover its peer from the database, and then it'll join the cluster as a second master node. Proceed to join agent nodes to it the same way that we did in the previous section. Go get the token, set it in the server URL, and then install K3s. At the time that this video was released, Ketchup didn't have an option for doing an HA installation, but one was under review. So just check the documentation and see if that's available now. K3d is a way to run K3s inside of Docker on your local machine. It's designed for developers to quickly spin local clusters up and down and build against them as they would against their production clusters. If you combine it with a tool like DevSpace, you can get a fast local development environment that accelerates every part of the process. You create a cluster with K3d cluster create, and then give it the name of the cluster. You can have multiple clusters on a single host. Each one gets its own network and its own IP space. You can stop the ones that you're not using, or you can delete them when you're done. If your kubeconfig environment variable points to a single file, K3d will merge the new cluster's kubeconfig into it. When you delete a cluster, K3d removes it from the kubeconfig. If you have the variable pointed to multiple files, then K3d won't do anything. You can fetch the kubeconfig with K3d kubeconfig get and then the name of the cluster. Save this to a file and then go on as you normally would. When you install K3d in a Linux environment, you'll get direct access to the cluster containers because the Docker network is part of the host network. But if you run K3d on macOS, well, Docker's running inside of a virtual machine that the base OS can't access. You see this here when I try to connect to 172.19.0.2, the address that traffic is using. Can't connect to it. So let's delete this cluster and create a new one with ports that are forwarded to the cluster's public addresses. To do this, we use -p and specify the local port, the target port, and the target node. Now that node can be the K3d load balancer, which is what we're using here, or it can be an indexed reference to server or agent where the first node is 0, the second is 1, and so on. Usually you'll just forward it to the load balancer for 80 and 443, or you can forward it to any agent for node port services. Now, when I curl localhost on port 8080, my traffic is forwarded to traffic on port 80, and I get the default backend. This felt unnatural to me, so I went looking for a better way. I found information online for using Tuntap on macOS to bridge the main host to the VM host. First, you need to install Tuntap, which you can do with Homebrew. It'll fail the first installation because you need to enable the kernel extension and system preferences. It tells you this during the install, and all you have to do is go enable it and then come back and run the install again. After Tuntap is installed, clone the Docker Tuntap OSX repository and run its install script. The link for the repo is in the video description. This script replaces the Docker binary with a shim that injects additional arguments to the creation of the virtual machine and then attaches a tap interface to it. It only needs to be run once, and after Docker restarts, we need to bring this interface up with the Docker tap up script. Unlike the install script, the tap up script needs to be run anytime the virtual machine restarts, which means anytime the host machine restarts or anytime that you stop and start Docker. After running the up script, you'll see a new tap interface appear in the output of ifconfig. Now, you can add a route to any container network via 10.0.75.2 and send packets directly to it. I know that the first cluster network is going to be 172.20.0.0, so I'll just add that route and then bring up a new K3d cluster without any port forwarding. Like I described earlier, you can see that the kube config was merged with the multi-master one from earlier, and I can easily switch between the two contexts. Once the cluster is up and traffic is running, I can get its IP, and when I hit it with curl, I get the default backend. So although it requires an extra step, I personally feel that the benefit of being able to reach the container network directly on any port far outweighs any drawback. I can hit sites and services on their actual ports, and this makes for a better, more natural development experience. How do you want to run K3s? On your laptop, on dedicated hardware, in a virtual machine, on a Raspberry Pi or an Intel NUC? The options are as infinite as your imagination, and believe me when I say that. K3s is installed in places that you would have never dreamt would run Kubernetes only a short while ago, and it's only going to keep growing. These are the most common ways of installing it, but it's also customizable. Check out the documentation or the help within the binary itself. You can add --help to any command, and it'll tell you about all the various things that you can do to make it run the way that you want it to. In the next video, you'll see me rebuild my home cluster for the last time again because of a failure with DQ Lite. This time, I went all out. HA with MySQL, Cilium for the CNI, and Glue as an API gateway. And while I haven't yet moved any of my home production workloads back over to it, I did just install a Quake 3 server into it because why not? If you want to know more about how to do that, check out episode 14 of my Coffee and Cloud Native show. I'll have a link for that at the end of the video. That's it for today. My name is Adrian Goins. This is what I do. Come hang out with me and learn cool stuff. Thanks for watching. We'll see you soon.